One notation that comes up very, very, very often in trigonometry and once we get into calculus is sine squared or cosine squared. So, what does it mean when they say sine squared like this? Well, it just means take the sine of something and then take that answer and square it. So, sine squared theta is our quick way of writing take the sine of theta and square it. Cosine squared theta would mean the same thing. So, when we are doing these calculations, they can get a little tricky. So let's give a couple of these a try. First of all, remember these are all going to be part of our 30, 60, 90 or 45, 45, 90 triangles. We should have those memorized. So opposite of the 30 degrees, remember this is 1, 2 square root of 3. The smallest side is a 1. The biggest side, the hypotenuse, is a 2, and we put the square root of 3 here. The 45, 45, 90 triangles, that's a 1, 1 square root of 2, so we get those sides labeled very quickly. Now, what is sine squared of pi over 4? Well, first we need to remember that the sine of pi over 4 is going to be 1 over the square root of 2. But what we want is sine squared. So that's going to be 1 over the square root of 2 squared. And when you square a fraction, we square the top and the bottom. So 1 squared is 1, square root of 2 squared is 2. So the sine squared of pi over 4 is 1/2. Let's try that one more time. Cosine squared of 60 degrees. So we go to our 60 degrees, adjacent over hypotenuse. That's going to be 1/2 is the cosine, but this is cosine squared. So we need to square that top and the bottom, and we get 1/4. Really quickly, what's the tangent of pi over 6? So remember pi over 6, that's 30 degrees. TOA. So we have 1 over the square root of 3, and then we're squaring it. Now, you may be saying, Mrs. Hoffman, I thought you said that we have to rationalize every single time. Well, when you're squaring, you may want to first do the squaring and then rationalize if that's necessary, because squaring square roots gets rid of them. So we're not going to rationalize these, and that will make things a little bit easier because 1 squared is 1 and square root of 3 squared is just 3. Now, we will also have to do things that are a little bit more complicated, like this problem right here. What is the sine of 60 degrees times the cosine of 45 degrees? So again, we just need to start getting really good at using our triangles. So sine of 60 degrees is square root of 3 over 2. Cosine of 45 degrees is 1 over the square root of 2. We'll go ahead and rationalize these. So square root of 3 over 2 times square root of 2 over 2. And then we need to remember how to multiply fractions and how to multiply radicals. So to multiply fractions, you multiply straight across the top and straight across the bottom. When you're multiplying square roots, remember we multiply insides with insides and outsides with outsides, but we don't mix them up together. So square root of 3 and square root of 2, the 2 and the 3 are inside. We multiply them to make a 6. The 2 and the 2 on the denominator are outsides. We multiply those together to make a 4. And the answer is square root of 6 over 4. These can get a little bit more complicated though, so we're going to have to rely on our understandings of fractions and multiplication and division and common denominators and all of those things. So let's look at this guy right here, b. So we have 2 or 2 over 1 times the cosine of pi over 3. So we come up to our special triangle, adjacent over hypotenuse, that's 1/2. Now, cotangent of pi over 4, that's the tangent of pi over 4, TOA, but it's the reciprocal of that. So what's the reciprocal of 1? 1. What happens here when we have 2 over 2 minus 1? Isn't that just 1 minus 1? And we get 0. So you can see as we're going through these problems, you need to sort of think through how are we doing each of these pieces? How are we taking care of these things? And do we need common denominators? Go back to all of those, 5th grade math rules.